Hi everybody, welcome back to the second video on the trapezoidal rule. I'm going to make a quick summary here at number 4 in your notes packet. So what I need you to do is just graph the 6 minus x from 0 to 5 one last time. So we know we come up 0, 6. We decrease by 1 on the y for every 1 on the x. Okay, this was the area we were trying to estimate right here. Okay, now this is my summary. So if we think back to 5 left-hand rectangles, I want you to, and you can page back if you want to, I'm not going to because I have it memorized, but your formula for your 5 left-hand rectangles on the front page was this. The total generalized estimated area that you boxed in for me was delta x times the quantity, y sub 0 plus y sub 1 plus y sub 2 plus y sub 3 plus y sub 4. That was our end result. For 5 right-hand rectangles, your total estimated area boxed in was delta x times y sub 1 plus y sub 2 plus y sub 3 plus y sub 4 plus y sub 5. And that's boxed in. We already formulated it. And finally, when we did the 5 trapezoids, our total estimated area that we boxed in previous pages was as follows. Delta x over 2 times y sub 0, 2y sub 1, 2y sub 2, 2y sub 3, 2y sub 4, and finally at the end a y sub 5. Okay, so you have these 3 formulas. Now what I want to do in this video is show you something really, really cool. If you find the average of your left-hand rectangles and your right-hand rectangles, if you average these 2 formulas together, you end up getting the trapezoidal approximation. Let me show you how this works. So to average something, you add whatever you're averaging together. So step 1, I'm actually going to bring it up here so I have space. So if I average left-hand rectangles and right-hand rectangles, then this is what it's going to look like. I'm going to have to add this guy to this guy. So let me do it this way. I'm going to recopy this guy here. I'm going to recopy him up here. So delta x times y sub 0 plus y sub 1, y sub 2, y sub 3, and y sub 4. And to him, I'm going to add this guy. Delta x times y sub 1 plus y sub 2 plus y sub 3 plus y sub 4 plus y sub 5. Okay, now when I add these together, it's kind of like adding like terms. I want you to think of this as being like, say this right here was 5. If you add 5x plus, say, 7x, you get 12x. So the thing that's common just comes along for the ride. So when you add these, think of the delta x as like your x, and then you add this part. So if I add y sub 0 to anything down here, I can't because there are no like terms, so I would just bring down the y sub 0. Now, we have 2 y sub 1s. So y sub 1 plus y sub 1 is 2 y sub 1s. Y sub 2 plus y sub 2 is 2 y sub 2s. Y sub 3 plus y sub 3, 2 y sub 3s. Y sub 4 plus y sub 4, 2 y sub 4s. And then last but not least, we just have the 1 y sub 5. So this is what happens if I add left and right hand approximations together. But to average something, not only do you add, you divide by how many things you're adding together. And in this case, I'm adding 2 things together. So I'm going to divide by 2. And if you compare this to the trapezoidal approximation down here, they're exactly the same. which just goes to show and prove that if you average the left and right-hand rectangle approximations, you will get the trapezoidal approximation, which is pretty cool. So here's the trapezoidal rule. We've derived it. Here's what it says. Trapezoidal rule. To approximate the definite integral from a to b of f of x dx, which basically means the area trapped between the x-axis and the function from a to b, where a to b is partitioned into n subintervals of equal length, delta x equals b minus a over n, use, and here it is, and we have derived it. Okay, the way you'll see it noted in textbooks, capital T. Capital T is for trapezoidal approximation, so the approximately symbol, and there it is, delta x over 2, and then times this quantity, y sub 0, plus 2y sub 1s, plus 2y sub 2s, plus dot 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 dot, plus 2y sub n minus 1s, plus your final y value, just one of them, y sub n. Interesting things to note, your initial y and your final y do not get multiplied by 2, only the y values on the interior of your interval. Okay, tune in to the third and final video to go through our example on how to use the trapezoidal rule.